The directions are going to say find the indicated sum, and we'll just talk about the summation symbol. It looks like a B, a really large E in a kind of a funky font, but there will be a number at the top and a number at the bottom. Okay, so we'll just say there'll be some number that we start with at the bottom and some number that we end with at the top. This is also something that when you get to calculus, you're going to do derivatives and integrals, and they're going to do limits, and your limits go the same way. You're going from the bottom limit to the top. This is the first symbol that we've seen anywhere until we get to this chapter. This is the summation symbol, and it's asking you to find a certain sequence. So you're going to find that sequence kind of like you did in last night's homework, but that symbol means that you're going to do a sum of all the numbers that are in the sequence. So the symbol means summation. The bottom number or the bottom limit is going to tell you what you're going to start with, and then the top one is going to tell you what you're going to end with. And then that symbol always means to add up the numbers in the sequence. They're not going to tell you always to add, but when you see that symbol, that's what it's going to mean as far as sum. So let's look at number 30. So this is the problem. We've got the summation symbol. What we're going to be plugging into is the 7i. We're going to be plugging I values into 7i, and we're going to start with the bottom limit, which is what means we're going to start where I is equal to 1, and we're going to do 1, 2, 3. We're going to plug in a 1, a 2, a 3, a 4, a 5, and a 6. That's going to give us so many numbers in our sequence, and then we're going to add those together. So when I is 1, 7 times 1 is 7. And we're going to add that with the number where I is 2. 7 times 2 is 14. Then we're going to add the next number in the sequence, which is 7 times 3, which is 21. Then we're going to add the next number in the sequence, which is when I is 4. So 7 times 4 is 28. Then what? 35. Then 42. So it's another way to find values in a sequence, but the symbol, the summation symbol, means once you find those, you're going to add them up. So then you would take your calculator, you would add all those up, and you get 147. So 147 is the answer. All right, you do number 32. You do number 32. So this looks really different to begin with because it's a different notation. You try 32. You could possibly do these without any work, but if you wanted some partial credit, you might want to show the work. All right, you'll have a final answer for this one? How much? It's 225. So 1 to the third is 1, plus 2 to the third is 8, plus 3 to the third is 27, plus 4 to the third is 64, plus 5 to the third is 125, and then you add those up. All right, you know they're going to get more complicated than this. Any questions about 32? Y'all ever seen the summation symbol on the ACT? I've never. You have? Once. I think it's probably rare. Yeah. All right, 34. We don't need to do 34. We'll do 36. 34 is same old, same old. All right. If you're not careful, you're always going to think that you start with 1. Okay? But on 36, the bottom limit is a 2. So if you're not careful, again, you're going to always think that you start with a 1. But that's not always true. So you're going to have to look at the bottom to see what you start with. And you're going to have to look at the top of the summation to see what you end with. So if you're not careful, you'll just start with 1 and go to 4 just because that's kind of the natural thing to do. Alright, so we need the summation of negative 1/3 to I from 2 to 4. So that's only going to create a number for when I is 2, a number when I is 3, and a number when I is 4. So what's negative 1/3 to the second power? 1/9. So I have 1/9 plus negative 1/3 to the third power is negative 1/27. And then lastly, negative 1/3 to the fourth power would be positive 1/81. And then I would definitely use my calculator to add up those fractions. Seven over 81. That's what I got. 7 over 81. Final answer, 7 over 81. So again, be careful. Do not assume that all summations start where I is 1. Okay? All right, let's look at 38. 38 is a little weird. All right, 38 is going to start where I is 3. And it's going to end when I is 7. But what's weird about this one is you're going to be plugging into 12. Okay? So what's weird about this is there's no what? There's no I. So if I is supposed to be 3, and you plug 3 in for I, and there's not an I, when I is 3, your function is 12. When I is 4, and you plug in 4, and then there's not an I, then your function is 12. So you just got to keep count. You have a 3, you have a 4, you have a 5, you have a 6, and you have a 7. So you're going to end up with 1, 2, 3, 4, 5, 12s. So if there's not an I to plug in, it doesn't matter what I is, you're going to get 12, the constant, every single time. So 12 times itself 5 times is 60. So that's what you do when you don't have an I. Okay? There are some problems that, let's look at 40 and 42. These get a little bit harder. Alright, this one's pretty crappy. So, sometimes what I do, so I don't leave anything out, is I write, just like I did on those 12s, I wrote the numbers that I was plugging in for I so I could keep up with how many I'm going to have. So I'm going to plug in a 0 through a 4. So 0, 1, 2, 3, and 4. You don't have to do this. This is just the obsessive me that wants to make sure I don't miss anything. So I'm going to end up adding 5 things. So when I is 0, I have negative 1 to the 0 plus 1, which would be 1 over 0 plus 1 factorial, which would be 1 factorial. If you can do that in your head, that's great, but what's that going to simplify to be? Negative 1 to the 1 divided by 1 factorial. Is that going to be negative 1? Okay. I'm going to do a little bit of work, then I'm going to go down and simplify it below that. When I is 1, then you're going to have negative 1 to the 1 plus 1, which is 2, over 1 plus 1, which is 2, which is 2 factorial. What's that going to be? That's going to be 1 over 2 times 1, so that's going to be positive 1/2. And I wouldn't overuse your calculator here. I think you can do most of this simplifying in your head. And then you're going to get negative 1 raised to the 3rd power. You'll start to see the pattern here. And then 2 plus 1 is 3, so then you'll have 3 factorial. So every single term is going to change what? Change signs and denominators. So then you'll end up with a negative 1 over what? 3 factorial. What's that? Y'all can do that in your head. 3 times 2 times 1 is 6. And then the next term should be positive, right? So we've done the 0. I'm running out of room. We've done the 1. We've done the 2. Now we're doing the 3. So negative 1 to the 3 plus 1. That's going to be negative 1 to the 4. We're doing 3. 3 plus 1 is 4. I wrote that in the wrong place. Negative 1 to the 4th over 4 factorial. You can start to see the pattern here. So what's 4 factorial? 4 times 3 is 12. 12 times 2 is 24. So that's positive 1 over 24. I've got one more. I'm just out of room. So the last one's going to be negative 1 to the 5th over 5 factorial. So that's going to be negative 1 over 5 factorial. $120? 120. And then you'll have to add all those up. Negative 1 plus 1/2 plus negative 1/6 plus 1 over 24 plus negative 1/20. Negative 19 over 30. Okay. All right, the last one that we're going to do in this section is going to have, I'm going to let you do this one. It's similar to 40. It's got a factorial in it. All right, everybody got 40? All right, 42. Yeah, I was so disappointed where because there were no web assigns for this chapter. And I was seeing y'all jumping up and down. Alright, so you're starting with 1, ending with 5. The summation of I plus 2 parentheses factorial over I factorial. Most of these factorials can be done without using your calculator if you really understand what they are. And a lot of times y'all are going to mess it up by trying to put it in your calculator. It's not that hard to do it without a calculator. Alright, the answer is 110. Does anybody need the terms that you would get to get 110? Does everybody get that one? Alright, good. I'm glad everybody got that one. Alright, the next set of directions, they're going to give you the problem, and you're going to come up, they're going to give you the answer per se, the summation of the terms, and then you're going to come up with the problem. Alright, this is always supposed to be a little bit more difficult. So the directions are going to say express each sum using summation notation. And they'll have to give you a little bit of information like this. They'll say use 1 as the lower limit. Use 1 as the lower limit, and you can use different variables, like all the ones that we've seen has I for the variable, but they call that variable an index. It doesn't mean it's a radical, but it says and I for the index. So in this material that we're looking at, that's just the variable that you start with on your lower limit. So you could use I, you could use X, but they're telling you to use I, so they're giving you some little restrictions here. So we'll start off with an easier one. Now this is harder to do, in my opinion, and they can get a little hard. Alright, so if you have 1 to the 4th plus 2 to the 4th plus 3 to the 4th, dot, 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 all the way to 12 to the 4th. So that's kind of like, that's your answer. They haven't added it up, but they'll leave it in that form right before they add it up. And they're wanting you to write a summation problem for that. So we'll do our little fancy E. We know on the bottom we're going to have I is equal to what? 1. Okay, they're not going to tell you the upper limit, but you can probably tell what the upper limit is going to be based on the changes in the terms. Okay? So what's not changing is the what? I shouldn't have written a +4 right there. But what's not changing is the 4. What's changing is the base. So this one's fairly easy, and this one would be I to the what? This one will be I to the 4th. They're telling you what your lower limit is, and so your upper limit, you're going to go all the way to that last term, and that last term would show you that your upper limit would be 12. So they're asking you to create the summation problem if they have the terms written out with the plus signs in between them. Alright, so as you can imagine, this is probably going to get harder. So let's jump to number 48. Same set of directions. Alright, so you have 1 plus 2 plus 3 plus ... plus 40. Lower limit is 1. You've got to figure out what your expression is going to be, what you're going to plug your 1 into, and then you've got to figure out what your upper limit can be. And I would say in this section, you could possibly have some different answers here. I would say some of these might fit into some different problems, possibly. Okay, 40 on the top, and then just an I. Just an I. So you would go back and you would say, does this make sense? So if I were 1, the first term would be 1. If I were 2, the second term would be 2, and so forth. Okay, let's look at number 50. Alright, number 50. 1 over 9, 2 over 9 squared, 3 over 9 cubed, ... plus n over 9 to the n. Again, we know our index is I. We know our bottom limit is 1. Upper limit is n. Did y'all get that? Just by looking at the last term. So the last thing that you're going to plug in is n. And maybe you can use that last term to figure out what your expression is going to be. I over 9 to the I. I over 9 to the I. I over 9 to the I. The 1 over 9, you might want to think about 9 having an exponent of 1. Maybe that helps a little bit. Okay? And then it's always hard when they just put variables in. So let's look at 54. It just has variables, no numbers. And then to me, this is where my brain just goes, whatever, and John Baylor would say, we need to attack this problem. Don't go, don't even get into that point. Don't get into that mental. So we know on the bottom we're going to have a 1. Okay, it would help me to put an AR to the 1, and it might even help me to think of that A as AR to the 0. Does that make any sense? So there is an R in every term, except that first term just had an A, so that R would be like R to the 0. We're starting where I is 1. Anybody figure it out? AR. How would you get 0 and then 1 and then 2? Say it louder. I minus 1. Telling y'all, Mary Arlen is like, she's doing so good in this class. All the way to the end. All right, last set of problems say express each sum using summation notation. Use a lower limit of your choice. So that means you don't have to start with 1 in this next set of directions. Express each sum using summation notation. Use a lower limit if you're talking hush. Use a lower limit of your choice. That means you don't have to start with 1 here. And K for your index. So this time, they're just getting tired of using I. They're going to use a K. So we could have different answers for these for sure because we're starting with a different number on the bottom. And then they don't get any harder than this section. I think this section is the hardest. And I think we could come up with different answers here, but we would have to just make sure that if we went back and worked the problem that we got 6, 8, 10, 12, yada, 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 and then 32. So they're asking us to use an index of K, so we'll do K equals. You don't have to start with 1. You've got to get 6 as your first term and 32 as your last term. These are harder.
You saw this or not? A message from Coach Campbell. Your phone.
Come to that. Okay. Who's that from? Can you see a name on there? Okay. Anybody figured it out? 2 is your lower limit? 3? You want to do one as 3? All right, you're going to do 3. What's your upper limit? 16. And what's your expression that you're plugging into? 2K? Would that work? 6. Would that one work? All right, I also had this one. I don't know why I thought of this one. I started with K of 2 and went to 15. Mine was actually harder. That one was easier. Anybody know what my expression would be if I started with 2 as my lower limit and 15 as my upper limit? $2K plus 2. I think I was thinking that I was adding 2 every single time. And that made a little bit more sense to me, but both of these work. Okay, if you get to start with your limit, there's probably more than one answer to all of these.